Hey everybody, we're back at building this TensorFlow implementation for our service. I'm going to upload shorter videos. I do these in like little segments straight up and edit them much longer. I'm just going to release the shorter ones. Editing is terrible. So where we left off is I implemented a very basic constant implementation, for our recommender service interface. This doesn't use TensorFlow. It's good for testing, just good for getting something out there that you can validate. But we want to implement our TensorFlow version of this recommender service. So let's go back up to this recommender service just so we can look at it and see what the interfaces are. I'm only going to focus on recommend right now. I'm not going to bother with update. We're just going to start with recommend, and then we'll get into update. So for recommend, what are we talking about here? Well, our interface that we want is to return a managed value of the recommender service. Managed lets us delegate to ZIO, properly managing this resource's life cycle, which is quite nice because TensorFlow has some resources that we're going to allocate, and we want to properly deallocate these. TensorFlow is an abstract machine, in my view. We're building a program here in Scala that's going to interact with that abstract machine. It's going to create a program in that abstract machine, and then it's going to evaluate that program in the abstract machine, then manipulate that program. And for us, those resources are going to be references to TensorFlow resources that contain everything in this abstract machine relevant to this implementation that we're going to want to allocate and deallocate. The primary mechanism we're going to use to interface with this abstract machine is the TensorFlow session, at least for this implementation. So we're going to create a service for our TensorFlow implementation that is going to contain a reference to the session. And this is what our client, being this program we're writing in Scala, is going to use to interface with the TensorFlow abstract machine. And here's our little subtype of recommender service for our implementation. It's sealed because I'm going to implement the recommend and update methods within Fresh itself. But the one aspect we're going to keep in our implementation is a reference to that session. So that gives us an idea of what we're going to be allocating and deallocating. We're going to allocate this session, and then we're going to deallocate this session. And we're going to be using zmanage, same pattern as before, where we're going to make a managed value from an acquire fresh method and a release fresh method. Of course, this isn't going to compile because I haven't actually defined these. We're just going to call close on our session. Be core, not client. This gives our clients, again, this reference to a managed value of only this service interface, this abstract service interface. But internally, we're able to acquire a resource that has additional data, and in this case, we're talking about session, that we will still have access to on release. We know for acquire fresh, at some point we need this session, because that's how we interface with this abstract machine, which we're going to need later. So how do we get that? Well, I'm going to say that we're going to do two things. We're going to create a graph here. This is going to be the container within which we're going to build our TensorFlow graph. And this is going to be the thing that implements our model. We're going to evaluate and manipulate both, evaluate our model and also change our model as we learn more data. Given a graph, we can allocate a session that is specific to this graph. And right now this graph is empty. We'll get back to that in a moment. But I want to just compile this as is. And what I'm expecting the failure is, of course, we haven't implemented anything in service, so it can't instantiate that. Of course, we're given this very nice helper message that tells us what those methods are. We indeed need one that's recommend. It says it's a task, it's a string. And then we have another called update, takes actual string, and again is a task, but provides a unit. This will compile, but it won't run because recommend is not implemented. What we're going to be doing for recommend is requesting an execution of something on our graph using the session. To execute something via the session on our graph, we use session.run. There's quite a few different things we can pass the session.run for it. In this case, I'm talking about retrieving something from the session, so I want to give it a fetches. In this case, I'm just going to give it a single fetch to make, and that's going to request the evaluation of that. What is that? And what are we going to have it return? We know the end result we want to be a string, but what do we get from our TensorFlow implementation? Right, up here, we've allocated our graph, and we've associated our session with our graph, but we need to now build stuff that goes into our TensorFlow program. We're going to call this the model. And we're just going to have a helper function here. It's going to take the recommender and the target graph and return a model. And this model is going to contain all the references we need for later execution as well as updating. It's all going to be contained within this graph, but we want pointers directly to bits of this graph. We're going to first talk about the abstract interface for this model, and then we'll talk about actually building this model. And for me, I break mine into inputs, variables, and outputs. These are loose groupings, so I'm just going to use them as just kind of hierarchical aspects. They're not going to have much semantic meaning. And I know that inputs is actually going to be empty right now. We'll get back to inputs later. Variables, though, there's really only one variable for our model here. If you recall way back when we were talking about how a really simple recommender should work, aside from the trivial ones that return constant or random, we had the idea of a population distribution that represented the preferences of a given flavor, or in this case, a choice. And we're going to guess what that is. We're going to estimate that, given the data, what people actually pick. We're going to store this estimated distribution as a variable within TensorFlow. Float for 0 to 1.0, representing the probability that a given choice is preference. This is actually a tensor of floats. It's not just a single float. And you can imagine that for our choices, we have one entry in this tensor per choice. And this is pretty much the entirety of our model, is just this estimated distribution of the population statistic of preferences. Outputs, well, that gives us a variable that's a resource within our TensorFlow program, but we need to read that. So our first output is the estimated distribution, so we can read that. That's going to be an output float, same type. We'll get to referencing that later. And the output of our recommender, which is a choice. That is the recommended choice. Now, our service interface uses a string for this choice. That's not very convenient for me to work with in TensorFlow, so I'm going to use an integer identifier for the choice, which is just going to be the index into the choices array that we're providing. And that's what our model is going to produce, this int. And now we're going to implement build model. We're going to take our recommender declaration, as well as our target graph. And it's going to return an instance of this model. Right. So now here we get to something interesting, which is TensorFlow for Scala uses a thread local variable to represent the target graph for constructor operations. I haven't really figured out a good way to just use the target graph directly, so I've structured this to be compatible with the TensorFlow for Scala mechanism, which is establishing the current context for the current thread. And that's create with. And that's going to say everything in this block is going to be created with this graph, meaning that as we use creation operations, they're going to be stored within this graph. Great. One is we want to references to the recommended choices. And of course, we're going to allocate a new model. And our inputs. Well, we have no inputs right now, so we'll get back to that later. And then our variables, we only have one real variable that we talked about. That is the estimated distribution. To construct a variable, we're going to use tf.variable and tell it we want to float. You can see down below there's quite a few arguments, but we're really only interested in the name, the shape, which, as I said, was going to be the same shape as our choices array, because we want those integers to be indexed within the choices, as well as how it's initialized. There's a variety of answers here for how you would want to initialize your estimated distribution. You might want something like, always initialize it to have the first choice be the maximal probability. I'm going to use random. I'm going to say I don't really know anything about the population preferences, so we're just going to start with a random set of assumptions. And then we want our outputs for this. And one output's really easy. We want to be able to examine this estimated distribution, and our estimated distribution output is just that. We just take the variable and we say, give us the output for it. Now we want the output for our choice. For us, we're really just interested in what is the most preferred index from our estimated distribution. And that is argmax. Those indexes start at 0, and the result type is int 32. So that compiles and works as we want it to. One part that is missing from this is we've told it to initialize our variables to random uniform initializer, but so far we've only allocated stuff. We haven't actually done anything. And one important step is to actually run these initializers. Whenever we manipulate our program within TensorFlow, this graph, we want to use tf.createWidth. This ensures that any additional resources are properly associated with that graph session. In this case, we're not actually interested in a result from this. I'm not even sure what the result would be from initializing all the global variables. We just really wanted to evaluate to some target. We're going to use as expected, and there is a global collection, we'll call it, in TensorFlow, called the global variables initializers, and this tf.global variables initializer says, hey, what we're going to be executing for our targets is all of the global variable initializer. With this done, we're ready to implement recommend. Recommend is going to run our TensorFlow program. Specifically, it's going to evaluate the output choice. In this case, we want the result of that output. We're going to use fetches, which lets us give a set of outputs that we want to evaluate to and get the results from. In our case, we only want the singular one, and if this will tell us what that gets. Right, so that gives us a tensor of 8. we know from how the outputs is implemented that we really only want one integer from this, and this is a tensor of size 1, so there is just a scalar from it. And that's the choice index is then just going to be, and then we take our recommender, which contains our choices, and we return back the choice that's at that index. And this says it's expecting a task of string, and we're actually returning back a string, because I forgot to say that we're running all of this in a task. Putting all of this in a task, make sure that any exceptions thrown from run or a valid index are going to be captured in this throwable. You probably want to use a better error type, but for this, throwable is going to be okay. And that should be sufficient for us to get a recommended choice. Let's check it out. And in D here, we see that we're running our little example program, and it's asking us to pick an ice cream flavor, and sure enough here, we now have a choice. Let's just go ahead and enter. And it says user selected more caramel. Let's go ahead and run that again. What I want to see is this initial recommendation random? Ah, look at that. Now it's caramel. We'll go ahead and select caramel, and we'll try again. Again, caramel. Go ahead and do this one more time. And now it's vanilla. Just taking the argmax, allocating a variable of that argmax, we're able to build a random recommender. In fact, we could implement update as doing nothing, and we would now have a complete implementation of a TensorFlow recommender for our recommender service that always provides a random recommendation. Not exactly what we want, because we want to update our estimated distribution, which is only random initially. We want to update this with actual choices that our users make and have this estimated distribution as we collect more actual usages get closer and closer to the population distribution. And we'll go over that next time. I think this is a pretty good point to stop on this video. If you want to check out the code, you can check the links down below. This has both the current state of this as well as the destination state in the draft packages. Go ahead and check that out if you're interested, and I will see you guys all next time.